Alright, so in the last lesson we looked at solving systems of equations using graphing. And remember, we've got a couple of strategies now that we could solve a system with. One would be guess and check, where we try x's and we try y's until we get the right answer, but that could take an awful long time. And we could take these two lines and we could graph them and see where the lines intersect. But not only do I have to mess around with rewriting these equations, but then I also have to have the problem of, boy, what if I don't graph them perfect? What if I can't exactly find the intersection? And so in this lesson, we're going to look at what is an algebraic way to solve these so that we can get an exact answer just by manipulating these around. And there's two algebraic techniques, and in this video, we're going to talk about one called substitution. So substitution takes 3 steps. The first step is you want to look at your system and solve for the easiest variable. In other words, I'm going to look at the x here, the y here, the x here, and the y here. I'm going to look at all 4 of those and say to myself, which variable would be the easiest to get by itself? And hopefully without too much thinking, you can figure out that x right there would be very easy to get alone. And the way I would do that is simply subtracting a 3y from both sides. So it's very easy, just one step, to get x by itself. Now, it's not always going to be x that's easiest to get by itself. Could be a y, could be in the first equation, we don't know, but you want to pick the easiest. Any variable will work, but why make more work for yourself? That's why I say pick the easiest. Now, I want you to understand something at this point, and this is really important for you to understand this concept. What I've created here is an equivalence, right? The equal sign means that the left side and the right side are the same thing. So x and negative 3y plus 3 are exactly the same thing. That's what the equal sign means. I can use them completely interchangeably. So I could say x, or I could say minus 3y plus 3, and I would be talking about the exact same thing. So now, at this point, the second step, we're going to do a substitution, and this is where the technique gets its name. So recall that my original equation, the other equation, so this deals with the other equation, the original other equation was 2x plus 5y equals negative 5. So 2x plus 5y equals negative 5. And that's what I mean when I say the other equation. Now, what I'm going to do is make a substitution. So right now, this says 2x plus 5y. But I know another way to talk about x. Because remember, x is the same thing as saying negative 3y plus 3. So I'm leveraging the equivalence I found up above. That x and 3y minus, negative 3y plus 3 are equal. So that right there is the same thing as x. So I haven't really changed my equation. Plus 5y equals 5. Now here's what's interesting. After I make that substitution, I am left with an equation that has exactly one variable, a y. So this is something I can solve. So I'll go ahead and use the distributive property here and here to get negative 6y plus 6 plus 5y equals 5. And then I'm going to combine some like terms, and I'm running out of room, so I'm going to go up here. And negative 6y and 5y, that's going to give me minus 1y plus 6 equals 5. I'll minus 6 from both sides. Negative y equals negative 1, or y equals positive 1. And so by doing that substitution, by understanding that x and negative 3y plus 3 are the same, I was able to make a substitution. I was able to replace x in there and get this variable by itself. Well, now that I have that, I'm home free. I know one of the two answers. I know that y is 1. So now at this point, I'm going to use that to get the other answer. So I'm going to pick one of the equations I started with. It really doesn't matter which one. And I've got two choices, of course. I've got the first one here, or the second one. Doesn't matter. Pick the one you like better. I think I'll do the first one. no particular reason. So I've got 2x plus 5y equals negative 5. Now remember, I know what the y is. I know y is 1. So I will substitute it. 2x plus 5 times 1, I already know what y is. That's not a mystery anymore. Equals negative 5. So 2x plus 5 equals negative 5. I will minus 5 from both sides. So 2x is negative 10, negative 5 and another negative 5. Divide by 2. And I'll end up with x equals negative 5. And I already knew y was 1, so there are my two answers. Alright, so let's do one more example of this. This one will go a little bit faster on, and I won't write down all the steps because you can look at those earlier in the video. But let's say for this one I want to solve 3x plus 2y equals 1, and negative 2x plus y equals 4. Now remember, the first step says which variable would be easiest to get by itself. And for me, I think it would be really easy to get y all alone. Because if I was to write that down, I would realize that all I had to do to get it by itself was to add 2x, right? I want to opposite those, to both sides. So I would end up with y equals 2x plus 4. So I was able to get that y by itself really, really easily. Now, the second step is to do a substitution into the other equation. So my other equation, that's the one I didn't use in step 1. So in step 1 I used the bottom equation, now I'm going to use the top. 3x plus 2y equals 1. Now, I now have a substitution I can make, because I know that saying y and saying 2x plus 4 is exactly the same thing. So 3x plus 2, and now here's my substitute, because I know another way to talk about y, 2x plus 4. So that's where it gets its name, substitution. And since now I only have one variable, x and x, I don't have a y anymore, I can solve this. So just like before, we're going to see a distributive property here. Right there, so 3x plus 4x plus 8 equals 1. 2 times 2 is 4, 2 times 4 is 8. And I'm going to combine like terms. 3x and 4x is 7x plus 8 equals 1. Minus 8 on both sides, so that 7x equals negative 7. Finally, divide by 7, and x equals negative 1. And just keep in mind, if at any point in the video I'm going too fast, you can always go back and rewind, or you can pause just to think through my work a little bit, because I know I'm moving through this fairly quickly. So now I've got x. So I just need to know what y is. So very simple, I'm going to make a substitution. Now, I don't care which equation I use at this point. Pick your favorite. I think I picked the second one last time. I'll pick the first one this time. 3, now here's the thing. I'm going to do 3x. Well, I know what x is. It's negative 1. I know the secret. I know that mystery is solved, so I'm just going to use it. Plus 2 times y equals 1. Let's move this up so we can see it a little better. And so that's negative 3, right? 3 times negative 1 plus 2y equals 1, and it's going to be pretty easy to get y by itself at this point. Whoops, plus 3, excuse me, not plus 1, plus 3. 2y equals 4. Divide by 2, y is 2. So y is 2. I had already figured out that x was negative 1, and there's my solution. Now, if you were to graph these two, they would intersect at 2, negative 1. Graphing would be a valid way. If we guessed and checked a whole lot, we could probably find that that 2 and negative 1 also work. But this way is probably just a little bit faster.